Marcus currently owns 200 songs in his iTunes collection. Every month, he adds 15 new songs. Write a formula for the number of songs in his iTunes collection as a function of the number of months M. How many songs will he own in a year? The initial value for this function is 200. Since he currently owns 200 songs, so n of 0 equals 200. The number of songs increases by 15 songs per month, so the rate of change is 15 songs per month. With this information, we can write the formula. N of m equals 200 plus 15m. N of m is an increasing linear function. With this formula, we can predict how many songs he will have in 1 year, 12 months. N of 12 equals 200 plus 15 times 12 equals 200 plus 180 equals 380. Marcus will have 380 songs in 12 months. Try it now. If you earn $30,000 per year and you spend $29,000 per year, write an equation for the amount of money you save after Y years if you start with nothing. Calculating rate of change. Given two values for the input, x1 and x2, and two corresponding values for the output, y1 and y2, or a set of points, x1, y1, and x2, y2, if we wish to find a linear function that contains both points, we can calculate the rate of change, m. M equals change in output divided by change in input equals y2 minus y1 divided by x2 minus x1. Rate of change of linear function is also called the slope of the line. Note, in function notation, y1 equals f of x1 and y2 equals f of x2, so we could equivalently write m equals f of x2 minus f of x1 divided by x2 minus x1. Example 2. The population of a city increased from 23,400 to 27,800 between 2002 and 2006. Find the rate of change of the population during this time span. The rate of change will relate the change in population to the change in time. The population increased by 27,800 minus 23,400 equals 4,400 people over the 4-year time interval. To find the rate of change, the number of people per year the population changed by, 4,400 people divided by 4 years equals 1,100 people per year equals 1,100 people per year. Notice that we knew the population was increasing, so we would expect our value for m to be positive. This is a quick way to check to see if your value is reasonable. Example 3. The pressure P in pounds per square inch on a diver depends upon their depth below the water surface, D, in feet. Following the equation, P of D equals 14.696 plus 0.434 D. Interpret the components of this function. The rate of change or slope, 0.434, would have units output divided by input equals pressure divided by depth equals per square inch divided by feet. This tells us the pressure on the diver increases by 0.434 per square inch for each foot their depth increases. The initial value, 14.696, will have the same units as the output. So this tells us that at a depth of 0 feet, the pressure on the diver will be 14.696 per square inch. Example 4. If f of x is a linear function, f of 3 equals negative 2 and f of 8 equals 1, find the rate of change. F of 3 equals negative 2 tells us that the input 3 corresponds with the output negative 2. and f of 8 equals 1 tells us that the input 8 corresponds with the output 1. To find the rate of change, we divide the change in output by the change in input. M equals change in output divided by change in input equals 1 minus negative 2 divided by 8 minus 3 equals 3/5. If desired, we could also write this as M equals 0.6. Note that it is not important which pair of values comes first in the subtraction so long as the first output value used corresponds with the first input value used. Try it now. Given the 2 points 2, 3, and 0, 4, find the rate of change. Is this function increasing or decreasing? We can now find the rate of change given two input-output pairs and can write an equation for a linear function once we have the rate of change and initial value. If we have two input-output pairs and they do not include the initial value of the function, then we will have to solve for it. Example 5. Write an equation for the linear function graph to the right. Looking at the graph, we might notice that it passes through the points 0, 7 and 4, 4. From the first value, we know the initial value of the function is b equals 7. So in this case, we will only need to calculate the rate of change. M equals 4 minus 7 divided by 4 minus 0 equals negative 3/4. This allows us to write the equation f of x equals 7 minus 3/4 x. Example 6. If f of x is a linear function, f of 3 equals negative 2 and f of 8 equals 1. Find an equation for the function. In example 3, we computed the rate of change to be m equals 3/5. In this case, we do not know the initial value of f of 0, so we will have to solve for it. Using the rate of change, we know the equation will have the form f of x equals b plus 3/5 x. Since we know the value of the function when x equals 3, we can evaluate the function at 3. f of 3 equals b plus 3/5 times 3. Since we know that f of 3 equals negative 2, we can substitute on the left side. Negative 2 equals b plus 3/5 times 3. This leaves us with an equation we can solve for the initial value. b equals negative 2 minus 9/5 equals negative 19/5. Combining this with the value for the rate of change, we can now write a formula for this function. f of x equals negative 19/5 plus 3/5 x. Example 7. Working as an insurance salesperson, Ilya earns a base salary and a commission on each new policy. So Ilya's weekly income, I, depends on the number of new policies, N, he sells during the week. Last week, he sold 3 new policies and earned $760 for the week. The week before, he sold 5 new policies and earned $920. Find an equation for I of N and interpret the meaning of the components of the equation. The given information gives us 2 input-output pairs, 3, 760, and 5, 920. We start by finding the rate of change. M equals 920 minus 760 divided by 5 minus 3 equals 160 divided by 2 equals 80. Keeping track of units can help us interpret this quantity. Income increased by $160 when the number of policies increased by 2, so the rate of change is $80 per policy. Ilya earns a commission of $80 for each policy sold during the week. We can then solve for the initial value. I of N equals B plus 80N. Then when N equals 3, I of 3 equals 760, giving 760 equals B plus 80 times 3. This allows us to solve for b. b equals 760 minus 80 times 3 equals 520. This value is the starting value for the function. This is Ilya's income when n equals 0, which means no new policies are sold. We can interpret this as Ilya's base salary for the week, which does not depend upon the number of policies sold. Writing the final equation, I of n equals 520 plus 80n. Our final interpretation is Ilya's base salary is $520 per week, and he earns an additional $80 commission for each policy sold each week. Example 8. Given the table below, write a linear equation that represents the table values. We can see that from the table, the initial value of rats is 1,000, so in the linear format, P of W equals B plus MW. B equals 1,000. Rather than solving for M, we can notice from the table that the population goes up by 80 for every 2 weeks that pass. This rate is consistent from week 0 to week 2, 4, and 6. The rate of change is 80 rats per 2 weeks. This can be simplified to 40 rats per week, and we can write P of W equals B plus MW as P of W equals 1,000 plus 40W. If you didn't notice this from the table, you could still solve for the slope using any 2 points from the table. For example, using 2, 1,080, and 6, 1,240, M equals 1,240 minus 1,080 divided by 6 minus 2 equals 160 divided by 4 equals 40 rats per week.